In this video, I'm going to be dealing with rational exponents. I am specifically making the video for the Math 105 class at IUK, and in their textbook this is section 7-2. However, anybody that would be dealing with rational exponents could benefit from this video as well. I do want to make a note that this is part 1 of 2. In this video I'm going to go through the definitions or the rules that were in section 7-2 with some examples after each definition, and then in the second video just simply work out several different examples where you're putting all of these different rules and definitions into play. Okay, so for our first definition here, I've got a to the 1 over n, and that can be rewritten as the nth root of a. Okay, this is going back and forth in between rational exponents and radical form. Alright, and it works going both ways. So just some examples to work through how this definition would work. Alright, let's say it says use radical notation to rewrite the expression, simplify if possible. Okay, so if I had 64 to the 1/2, alright, so 1's on top, 2 is the denominator there, so that means that's going to be my root. So this would be the second root, or the square root of 64, and I can simplify this. Square root of 64 is 8. Okay, so again here on this one, I've got in parentheses a negative 125. Okay, so that means that's my entire base being raised to the 1/3. So it's going to be the third root, the cube root of negative 125. And if you recall, you can take cube roots of negative numbers. So that's going to be negative 5. And here again in this last example here, my entire base is indicated as the 6x squared y because of the set of parentheses there being raised to the 1/5, which means it's going to be the fifth root of that 6x squared y for the whole entire thing. Okay, so real easy implementation of that rule. Alright, now let's show the rule going the other direction. Okay, how about if it said rewrite with rational exponents and they gave it to you in square root form, 5th root, 7th root. Okay, so this would be the 5th root of 13ab, and that's all to the first power. Alright, so I would rewrite as 13ab, that being my entire base because the entire thing is underneath the radical, and then raised to the 1/5. Okay, and then same thing over here. This entire thing right here has raised to the first power right there. It's the 7th root. So since that's the entire base, I would write x y squared over 17 raised to the 1/7 power. Alright, so implementing that first rule both directions. Okay, now the second definition that we're going to do is pretty much the exact same thing, except it's not going to have a 1 in the top. This rule also works for any fraction, so m over n. The denominator is always the root. The numerator is what's being raised to. Now, on this one, we could place it a couple different ways. Alright, I could do the nth root of a and then raise it to the nth power, or I could do the nth root of a to the m. Alright, now this one I would venture to say you're not going to use very often, because as soon as you go a raised to the m power, that becomes a very, very large number, which then makes taking the nth root a little more challenging. So if you take the root first and then raise it to that exponent, it allows you to do the math probably a little bit easier and do it in your head definitely without probably a calculator. Alright, some examples of this. Alright, the directions might say use radical notation to rewrite each expression and simplify. So then they might give us 1,000 raised to the 2/3. Okay, so now you've got to remember that bottom denominator is going to be the root. So this is going to be the third root of 1,000 and then squared. Alright, and this is very definitely going to be easier to do it this way than if I tried to take 1,000 and then squared it and then take the cube root. I'd have a really big number. Don't want to do that. Okay, cube root of 1,000 is 10, and I still have to square it. 10 squared is 100. Okay, now on this one right here, alright, you kind of got to be careful on what the actual base is. The actual base of this is really 32. Alright, there is no set of parentheses. It is not negative 32. If I rewrite over here, negative 32 to the 3/5. Alright, really technically there's an imaginary negative 1 that's sitting in front of it. So my only base here is the 32. Okay, so that means I'm going to have negative, and then my root will be the fifth root of 32, and then I want to cube it because it's going to be easier to find. Okay, so the fifth root of 32 is going to be 2. That negative is going to be out in front. And then I'm going to raise it to the third power. 2 to the third power is 8, so I'm going to have a negative 8. Alright, now going the other direction with this rule. Okay, what if it tells you to rewrite with rational exponents, and this time they're giving you cube root or fifth root with a power involved there. Okay, now this root is always the denominator, and that's the numerator, so rewriting this with a rational exponent would be 6 raised to the 4/3. Alright, and then this one, the fifth root there would be my denominator of the fraction, the 7 would be the numerator. So I'd have a 2xy raised to the 7/5. Okay, so that rule implemented. Alright, now we've got one more rule that we want to take a look at here real quick. This one kind of follows along with your laws of exponents. Alright, let's say I've got a raised to the negative m over n. Alright, if you recall just from a regular negative exponent, we can move it to the bottom. Alright, and make it positive. Alright, which I need to, whoops, get my white out there and take that off there right there. Alright, if you've got a negative exponent like this and you move it to the bottom, then it makes your exponent positive. So an a raised to the negative m over n would be 1 over a raised to the m over n, the positive m over n. So in this example right here, rewrite each expression with a positive exponent. So they're telling you what to do. Simplify if possible. Okay, so this entire expression is going to get moved to the bottom. I'm going to have a 1 on top, and it'll be a positive 3/5. Alright, now it does say simplify if possible, so then now I've got a rational exponent here, and with our last rule we learned that this could be the fifth root and then raised to the third power. So I'm going to have I'm going to go sideways on this one, I think. 1 over the fifth root of 32 cubed. Alright, now fifth root of 32 is a 3, or fifth root of 32 is 2, so I'm going to have a 1 over 2 to the third, and 2 to the third is 8, so then I'll have a final answer of 1/8. So that's kind of implementing this rule first, and then using the previous rule to simplify and go a little bit farther. Okay, so on this one, I need a positive exponent first, so I'm going to apply this rule up here first. So I'm going to go 1 over a 125 to the 1/3. Makes it a positive 1/3. Alright, now it says simplify if possible, so now I'm going to make this the third root. So the third root of 125. Alright, and then to the first power, but I don't need that there. And now the third root of 125 is 5. So it simplifies down to a 1/5. Okay, so basically this is your 3 definitions that are in the very beginning of section 5-2 for those students that are in Math 105 at IUK. Alright, however, there are 3 basic rules that deal with rational exponents for anybody. Alright, the part 2 video is going to take all of these rules, and we're just going to do lots of examples implementing these to be able to simplify problems. So definitely thanks for watching, and be sure and share with your friends. Thanks.